Yeah, so this is about, so I didn't compute. So what I mean by not computing is, for example, if A1 is given as 3 and A2 is given, no, actually R, I should say, A1 is given as 3 and R is given as 2, then I didn't compute. I didn't make this to be 6 right away, because if you make the 6, if you make A2 6 right away, then you don't really see the patterns, like what kinds of patterns that are underlying, you don't really see the underlying patterns here. So by not fully computing, you're able to see the patterns more clearly. Okay, now let's do the recursive one here. If you do recursive one, then everything should be done with algebra and algebra only. Then what that means is, now you have A2 over A1, and then A3, this is also R, and then think about multiplying them horizontally again. Okay, then an over an minus 1 all the way to an over n minus 1. Then we do have n minus 1 r's multiplied all together like this. Then as you see, A2, they cancel each other out. A3, they cancel each other out. And then an minus 1, they will cancel each other out. The only thing that is left here are an and a1. Therefore, an over a1 is rn minus 1. Therefore, it is an, a1, rn minus 1. Whichever way you go, you get the same result. So I prefer, well, in this case, like these sequences are too easy, like geometric sequence, and then I just talked about arithmetic sequence. These two sequences are really, really easy. Therefore, well, you should be able to go back and forth with this. So, like easy sequences, I kind of prefer these recursive way better, because we already do know a general term of the arithmetic sequence and a geometric sequence, right? So now let's move on to the next sequence, which is a quadratic sequence. Quadratic sequence, this is kind of a British term, I think, and the sequence of a sequence is more of an American term. And now, here, Bn is an arithmetic sequence. So let's just suppose that its common difference is just d. Okay, then what we have here is, first of all, let's use the first one. Then now we do not want to compute anything. We just want to plug in numbers here. Then it's a2 minus a1 is b1, right? Then we have a3 minus a2 is b1 plus d, right? Because it is a geometric sequence, right? Now I think I went too far there. So I skipped some steps here. It's b2, right? So then b2 is b1 plus d, right? Why? Because bn is an arithmetic sequence here. And then a4 minus a3. So I keep plugging in numbers into n. I plugged in 2 into n, 3 into n. Then this is b3, and this is b1 plus 2d, right? So now in this case, how do we see, how are we able to find patterns here so that we can get a general term of this, right? So now so what did I say? Please do not compute. Do not compute. Okay. Then a2 can be rewritten as a1 plus b1, right? Then a3 can be rewritten as a2 plus b2, right? But now we do know how to rewrite a2 with a1 plus b1. Therefore, this is a1 plus b1, because I replace a2 with this expression here, and then you have b2 there, right? We know that a4 is a3 plus b3, right? In this case, we do know that a3 can be replaced by a1 plus b1. So I'm substituting a1 plus b1 there, a1 plus b1 plus b2 there, right? Because this whole thing here is a3, so I just put it right here. Then we have plus b3 here. Now we definitely see the patterns here, where we have 2, then this 1 and 1, and 3, then this is, we have 3 terms, right? 3 terms is a1, b1, b2. so it stops at 2. It's 4, it stops at 3, right? Then if it is A5, then it will stop at 4, right? Therefore, if it is AN, we go down. If we reach AN, it starts with A1 because every term here starts with A1, right? A1, A1, A1. Therefore, it starts with A1, and then we add from B1 all the way up to Bn minus 1, right? And you definitely see that when this is 2, this is 1. This is 3, this is 2. And this is 4, this is 3. When this is n, this is n minus 1. But we also do know that Bn here is an arithmetic sequence, and we do also know that how to get the sum of the arithmetic sequence here. Then if we simplify this, then what happens here is that An is A1 plus K is from 1 to all the way up to n minus 1 and Bk, right? But we do know that this Bk is an arithmetic sequence, so now B1 plus the Bn minus 1 and divided by 2 and times n minus 1. So this can be calculated this way effectively. So this is a general term. This is a general term of an arithmetic sequence. A quadratic sequence. Why is it a quadratic sequence? Because when you get a sum of any arithmetic sequence, then it's always you get a quadratic here. You get a quadratic here. If you're not convinced, think about this. So now if you have so like let's just say Bn is n, right? Then B1 is 1 and Bn minus 1 is n minus 1. Therefore, adding these two, 1 plus n minus 1 divided by 2 and times n minus 1. Now, this eradicate each other. Then you have n minus 1 over 2. This is a quadratic because you have n squared here, right? So now, well, I really hope that you find this really useful, where you just see patterns by not computing fully, right? And also, what is that? This little sequence Bn could be a geometric sequence as well. But by using the first method, well, what I can say is that using the first method works every time. Okay, using the first method here works every time. Okay, now let's do this algebraically. All right. Okay, let's do this algebraically. Then A2 minus A1 is B1, right? And then A3 minus A2 is B2. Now you're adding all the way up to An minus 1, and this is Bn minus 1, right? Because this n and this n should be equal 1, 1, 2, 2, n minus 1, n minus 1. Like we did in the case of arithmetic sequence, we are adding everything here. Then now, as you see, A2 they go away, and A3 like they cancel each other out, and the An minus 1 they cancel each other out. So An and the A1 are the only thing that you see on the left hand side. Therefore An minus A1. Then now you have the sum of K1 all the way up to n minus 1 and Bk, right? So again, whichever way you go, whichever way you choose, you will end up in the same you'll end up getting the same result. Okay, so then, okay, teacher, what if this is a not an arithmetic sequence? What if that's a geometric sequence? Then what happens here is that since now B1 and B2 and all of these are geometric sequence, then now it should be the general term should be computed this way: A1 plus again it's K1 all the way up to n minus 1 Bk. But now we do know that this is a geometric sequence in this case. Then what happens here is that it's A1 plus B1 R n minus 1 and then R minus 1. So this could be computed this way. Okay, so but this is a very rare case. So for example, no, I'll just stop here.